Hi all, welcome back to day 11 of 100 Days to CAT Quant series by the Gurukul. So today we'll be discussing 5 questions from the module number system. So whenever you come across a question on the screen, do pause the video, try solving that question, and once you're done solving, you can resume the video. Now coming to the first question, we are asked to find the last digit of the expression 4 plus 9 square plus 4 cube plus 9 power 4 plus 4 power 5 plus 9 power 6 so on till 4 power 99 plus 9 power 100, right? So if you observe, we have odd powers of 4 and even powers of 9. So let me write them separately. 4 plus 4 cube plus 4 power 5 plus 4 power 7 so on till 4 power 99. Now how many terms do we have? We have 50 terms, right? Now similarly we have 9 square plus 9 power 4 plus 9 power 6 plus so on till 9 power 100. Again we have 50 terms. Now first let's look at this. Now what is 9 square? 81. Now and if you observe the question carefully, we are asked to find the last digit only. So let's focus on the last digit, the units digit, right? Now what is the units digit of 9 square? 1. Now 81 square, again that will end with 1, right? 81 power 3, again that will end with 1 so on till 9 power 100. So you have how many ones? 50 ones. So last digit would be 0, right? Now coming to 4 plus 4 cube plus 4 power 5 plus 4 power 7 so on, right? Now 4, now what is 4 cube? 64. So you, that also ends with 4. Now 4 power 5, right? Now 64 into 4, that would end with 6, into 4, that would end with 4. Now if you observe, all the odd powers of 4 will end with 4. So this will also end with 4, this will also end with 4, so on till 4 power 99 will also end with 4. So how many 4s do we have? We have 50 4s. So 50 into 4, 200. Now the units digit is also 0. Now the units digit in the expansion of or in the summation of these two will be 0 plus 0. So 0, option A, should be the answer for this question. So whenever you are asked to find the units digit of any expression, our focus should always be on the units digit only. Now coming to the second question. If A, B and C are positive integers such that A minus B plus C into B minus C plus A into C minus A plus B is equal to 15, then what is the product of A, B and C? Now first, let's think about how can we factorize 15 as a product of three numbers. Now one way is 1 into 15, right? So this could be 1, this could be 1 and this could be 15, or this could be 15, this could be 1, this could be 1, right? So the values of A, B and C interchange among themselves, right? So let me consider A minus B plus C is equal to 1, B minus C plus A is equal to 1, C minus A plus B is equal to 15. Now if you observe, if I add these two, minus B and plus B will get cancelled, plus C minus C will get cancelled. So you have 2A is equal to 2. This implies A is equal to 1. Now if you consider this and this to be 1, then you'll end up getting C is equal to 1. And here you have A is equal to 1. That's it. There won't be any difference. Right. Now if A is equal to 1, if I substitute that here, 1 minus B plus C is equal to 1. I can cancel 1 on both sides. C minus B is equal to 0 or C is equal to B. Right. Now C minus A plus B is equal to 15. So C minus 1 plus B is equal to 15. So C plus B is equal to 16. Now we also got the values of C and B are same. So the value of C is 8 and B is 8. So when I consider these three expressions to be 1, 1 and 15, right? So value of A is equal to 1, value of B is equal to 8, value of C is equal to 8. Now what was asked? We are asked to find the product of A, B and C. So 1 into 8 into 8, 64, right? So students might mark this answer as 64, but let's hold now, right? Now, is 1 into 1 into 15 the only way of writing 15 as a product of three numbers? No. I could also write this as 1 into 3 into 5. Now, this is another way of writing 15 as a product of three numbers. Right. So, if I consider a minus b plus c is equal to 1, b minus c plus a is equal to 3. If I add these two, we have 2a is equal to 4 or a is equal to 2. Right. Now, if a is equal to 2, then 2 minus b plus c is equal to 1, or sending these two to right hand side, b minus c is equal to 1. Right. Now, let us substitute the value of a as 2 in this expression. So, c minus 2 plus b is equal to 5. So, c plus b is equal to 7. Now, we have b minus c is equal to 1. Now, if I add these two, you can cancel out c and minus c. So, we have 2b is equal to 8 or b is equal to 4. Right. Now, in this case, we have a as 2, b as 4. Now, b minus c is equal to 1. So, the value of c has to be 3. Now, what is the product of a, b, c now? 2 into 4, 8. 8 into 3, 24. So, if you observe, there are two different values for product of a, b and c. So, that could be either 64 or 24. So, the answer for this question should be cannot be determined. You have two answers for this question. Now, coming to the third question, find the maximum value of n such that 570 into 60 into 30 into 90 into 100 into 500 into 700 into 343 into 720 into 81 is perfectly divisible by 30 power n. Now, to understand this, let us consider a simple example. So, 6,000 divided by 3,000, right? 600 divided by 3,000 and 900 divided by 3,000. Now, which of these three, 600, 6,000 and 900 is divisible, is exactly divisible by 3,000? 6,000. Because, how can I write 6,000? 2 into 3 into 10 power 3, and denominator you have 3 into 10 power 3. So, the power of 3 in the denominator is equal to power of 3 in the numerator. Again, the power of 10 in the denominator is equal to power of 10 in the numerator. So, that's the reason that this is exactly divisible by 3000, right? Or the power of 3 in the numerator should be greater than power of 3 in the denominator, and also the power of 10 in the numerator should be greater than power of 10 in the denominator. Then only it will be exactly divisible. For example, if I consider this 2 into 3 into 10 square. Now what do we have? 3 into 10 cube. I can cancel 3 and 3. But 100 is not exactly divisible by 1000. Now why is 600 not divisible by 3000? Because the power of 10 in the numerator is less than power of 10 in the denominator. Right? Now similarly 900 by 3000. So I can write this as 3 square into 10 square. Here 3 into 10 cube. Right? Now I can cancel this. Power of 3 in the numerator is greater than power of 3 in the denominator. But the critical case here is power of 10. Right. So you have 10 power 2 in the numerator, whereas you have 10 cube in the denominator. So that's the reason 900 is not exactly divisible by 3000. Same logic can be applied here as well. Right. Now let's find the highest powers of 3 and highest powers of 10 in all the terms, the product of all these terms in the numerator. Right. And I can also say that between, for example, if I can write this as 3 power x into 10 power y into some number, I can say that x will be greater than y. 3 powers in the product of these terms will be greater than 10 powers, because 57 is nothing but this is divisible by 3. you have 1 3 here, you have 1 3 here, you have 1 3, you have 2 3s here, then you have this is 3 power 5, and you have 3 square here, and you have 3 power 4 here. So the powers of 3, right, is greater than powers of 10, right? So the critical case here is power of 10. Now let us see how many tens are there in the numerator. So 570 you have 110, 60 you have 110, 30 you have 110, 90 you have 110, 100 you have 2 tens, 500 again you have 2 tens because 5 into 100, 700 you have 2 tens, 343 no 10, 720 110. Now what is the highest power of 10? 1 2 3 4 5, 5 plus 6 11. So you have some number into 10 power 11 into 3 power n into 10 power n, and I can say that you have enough number of 3 powers, right? So the critical case here is the number to the power of 10, right? So for this to be exactly divisible by this, the maximum value of n is equal to 11, right? If the value of n is 12, then the numerator is not exactly divisible by the denominator, right? So the maximum value of n is 11. Now coming to the fourth question, what will be the value of x for 100 power 17 minus 1 plus 100 power 34 plus x when divided by 9, the remainder is 0, and that means the numerator has to be exactly divisible by 9, right? Now let's split this. So we have 100 power 17 minus 1 by 9 plus 100 power 34 plus x by 9. Now what is the divisibility rule of 9? For any number to be divisible by 9, the sum of all the digits has to be divisible by 9. Now if you observe 100 power 17, you will be having 1 0 0 so on till 34 zeros minus 1. What do we have? 9 9 9 so on till 13, 33 nines, right? So 33 nines. Now 99 is divisible by 9. 999 is divisible by 9. 9999 is divisible by 9. So if you have 33 nines, that would be divisible by 9, right? So the remainder is 0 when 100 power 17 minus 1 when divided by 9. So you do not have any remainder in this case. Now for this to be divisible by 9, again sum of all the numbers uh, should be 9 multiple, right? So 100 power 34, which is nothing but 10 power 68. So you will be having 1 so on till 68 zeros plus x. Now for this to be divisible by 9, sum of all the terms, sum of all the digits should be divisible by 9. So 1 plus 0 plus 0 plus 0 so on till 68 zeros plus x. So 1 plus x should be divisible by 9. So what should be the value of x? 8. So the answer for this question should be option D. Now coming to the fifth question, the greatest number which will divide 116, 221 and 356, leaving the same remainder in each case, right? Now whenever you come across these types of questions where you have three numbers, and if you are asked to find the greatest number which will divide these three and leave the same remainder, then all you need to do is you need to first find the difference between two terms. Now what's the difference between 221 and 116? 105. Again, difference between 356 and 221, 135. Right. Now, once you have these two differences, you need to find the HCF of 105 and 135. Right. So I can see that these two are multiples of 5. So 521s, 527s. Again, you have a common factor 3 for both 21 and 27. So 3 sevens 21, 3 nines 27. Now since 7 and 9 are co-primes, we'll stop here. So the HCF of these two numbers would be 5 into 3, 15. So the answer for this question should be 15, hence option A.